How high will a 0.325 kilogram rock go if thrown straight up by someone who does 115 joules of work on it? Ignore air resistance. All right? The trick on this one is they told you how much energy the rock had, and obviously it was given kinetic energy in this case, which means it had a velocity going straight up. If we can find the velocity that it had going up, we can figure out how high the peak was and how long it took to get to the peak and all that stuff. Well, the first trick is getting to the velocity. So kinetic energy equals 1/2 mv squared. So let me just toss in the values. So the kinetic energy in this case is 115 is equal to, I'm going to write 1/2 as a 0.5 times, the mass was 0.325. Whoops. 0.325 times v squared. And that's just a matter of solving for v squared. So you take all this stuff, and after doing a little bit of math down here, you find that the velocity equals 26 meters per second. All I did was just solve to get the v by itself down here. Should be pretty comfortable for you. So now we know how fast the thing was thrown straight up. So you just got the problem where the thing was thrown up with a velocity of 26 meters per second. And I've asked this one a bunch in class. If I throw it straight up at 26 meters per second, every second it gets 10 slower, which means the amount of time to get to the peak, the amount of time to lose all 26 of the velocity is 2.6 seconds, because you're losing approximately 10 every second. And we can use the peak trick where it took 2.6 seconds to get to the peak, and the average velocity on the way going up was 13 meters per second. Think about it. You launched it at a starting speed of 26, and then at the top it was 0. So the average speed going up was a speed of 13. And then to find the height of the peak, it's just average velocity times time. If you went up an average of 13 meters every second, and you did it for 2.6 seconds, then it just ends up being about 33.8 meters high at the peak. An 80-gram arrow is fired from a bow whose string exerts an average force of 95 newtons on the arrow over a distance of 80 centimeters. What is the speed of the arrow as it leaves the bow? Before we even start this, it's given us junk in grams and centimeters and newtons. Make sure all of your units are exactly what they're supposed to be. In this class, everything's got to be in kilograms and meters and newtons and all that stuff. So 80 grams is equal to 0.08 kilograms. I'm going to fix that before we even start the problem. Just convert all this junk. The force is 95 newtons. That's fine because that's the correct unit. And 80 centimeters, that's actually 0.8 meters. Right? The thing that you need to see here is we're giving this thing kinetic energy. At the beginning, it's elastic energy in the bow, but that energy gets spent and turns into kinetic energy on this arrow. So you know that we're going to have to use possibly this, and we also have to take advantage of the fact that work tells you how much energy was added to the system, which is equal to the force times the distance. So recognizing that, we use this fact to just calculate the amount of energy that was given to this thing as it was pushed by the bow. So the amount of work done is force times distance. You just toss the numbers in, and you get 76 joules of kinetic energy were added to the arrow as it was shot. So all we got to do is just bust out a little bit of math. The amount of kinetic energy was 76, and that has to be 1/2 mv squared for the object. So 76 equals 1/2 times the mass, which is 0.08, and we're looking for v squared. We're trying to solve for that. So now that we have an expression here, it's just a matter of solving for v. So to get the v by itself, we have to divide out the 0.04 and then hit a square root on it. And you get 43 meters per second. Pretty darn fast for an arrow.